In this video, I will be replacing a 20-pin IC chip. I will also list the tools that I will be using to perform this task from removal to replacement. The goal here is to use the least amount of heat possible, as these chips are sensitive to high temps over an extended period of time. This video is intended to help anyone from a beginner or hobbyist to professionals who are looking for alternative ways of removing IC chips from PCBs. The part that is not shown in the video, but it is best practice to preheat your PCB mainly within 2 inches around the area you are planning to rework. For thin boards, start by preheating the PCB to 100 degrees Celsius to 130 degrees Celsius or 212 degrees Fahrenheit to 266 degrees Fahrenheit. For thicker boards, preheat up to 150 degrees Celsius or 302 degrees Fahrenheit. Preheating your board reduces thermal stress, prevents board warping or pad lifting. Also allows solder to flow faster when you apply your iron or hot air. Here I'm using the WEP 2009D2 hot air station, set to 480 degrees Celsius, 896 degrees Fahrenheit, with the air speed at medium-high. I'm primarily focusing on heating the pins and avoiding overheating the center of the chip. This component is defective. However, best practice is to remove it properly to prevent damage to the PCB pads and surrounding components, ensuring a clean and reliable replacement. I'm using an infrared digital thermometer to ensure the board temperature stays below 200 degrees Celsius or 392 degrees Fahrenheit, since this is a thicker board. Let's add a bit of flux to the pads. I'm using a Smechuan model, RMA 799. It's okay to add a generous amount, but remember, the more you use, the more you will have to clean up afterwards. I will add a bit of flux also to the solder wick. This helps the old solder on the pads flow up into the braid more effectively. Lightly rub across each pad with the solder braid and give it a few seconds to saturate the wick. The soldering unit I'm using is the KSGR T12 soldering iron station, with the temperature set to 400 degrees Celsius, 752 degrees Fahrenheit. I'm using tip number T12 B1. Now it's time to remove the flux paste residue. Add small quantities of 99% rubbing alcohol to the board and on a cotton swab, or use an electronic swab to clean up. I typically blow on the board while I'm wiping off residue, as this shows me how much is removed and speeds up the evaporation process. Now it's time to place the new IC onto the board. I chose to use my finger to hold down the chip to show you that it's possible to hold down the chip till you solder your first pin. I'd recommend you only perform this method to secure the first pin with a cold chip and static-free gloves. A lot of techs have done it at some point, especially quick repairs, but in a professional or repeatable workflow, it's avoided. I'll now add flux to both sides of the IC. Adding a small amount of solder to the tip of the iron, I transfer the solder from the tip to the pin and distribute it evenly across each leg. If bridging occurs, that is okay. First, apply a small amount of flux and attempt to move the excess solder across adjacent pins. If that does not resolve the issue, use solder wick to remove the excess from the affected area. Afterward, apply flux again and redistribute solder back onto the pins where it was removed to ensure proper coverage and connection. While solder paste and hot air could have been used to place the IC by applying paste to the pads and reflowing the component into position. This method demonstrates an alternative approach that provides greater control, particularly when working near heat-sensitive components or when minimizing thermal stress on the newly installed device is a priority. Now it's time for cleanup. Remove as much residue as possible from the board, component, and between the component's legs. If flux gets caked between the pins, use the alcohol and brush to gently brush the flux from between the pins. Now that the chip is cleaned up, let's zoom in and confirm all pins are connected and proper adhesion has been achieved. If this video has helped you in any way, please leave a comment. If there are other components you'd like to see replaced, removed, or installed, drop those in the comments as well. Consider subscribing for more repair and soldering content, and give the video a like to support the channel. Also, check the description for tools and materials used along with any additional notes that may help with your own projects.